Hi everyone, and welcome to the 2.7 video. This one's going to be a couple of videos that are spliced together because for some reason the original video was ruined. So let's go ahead and go through this, and I'm going to cut it into the other video. And sorry if it's not the best quality, but we got to deal with what we got to deal with. All right, so 2.7. We're going to deal with segments and proof reference. So basically what we did last class, for the most part, we're just going to kind of recap. Anyway, so we have the reflexive property of congruence, and that is for any segment AB equals AB. So when you think about it, right, when some things are congruent, it just means that their shape and their size are the same. So it's saying the distance from A to B, which is a segment, is going to be congruent to the distance from A to B, which is also a segment. So it just means they're exactly the same. Congruence, just think about it. They have to be the same symbols, same letters. Symmetric property of congruence, well, that just means that if you flip it over, it's going to be the same, like a reflection or symmetric. So we could say that if we had like a triangle and pretend it's perfect, and I drew a line down it, and I flipped it over that line, it would work perfectly. Or if I had a square and I bent it in half. So if you think about it, if I went ahead and I drew a line here, and I took this and I flipped it over that line, it would look like this. So that's what the symmetric property of congruence. Then we have the transitive property of congruence, which says that if segment AB is congruent to CD, and CD is congruent to EF, then AB is congruent to EF. Notice that right here and right here is what is there. And since this is the same in the middle, we can cut that out. It's just like saying, you know, John's brother is David, and, you know, assuming everything is same parents, David's brother is Bill. So we could say that John is brothers with Bill in some way, okay? Definition of congruence. So congruence, right? Same shape, same size, right? If segment AB is congruent to CD, then AB has to equal CD in size. And if AB equals CD, then segment AB has to be congruent to segment CD. So it's just saying congruence, same shape, same size. Definition of a midpoint. Well, if the midpoint of a segment divides the segment to two equal congruent parts, if M is the midpoint of AB, then AM equals MB. So think about it. You have a segment A and B. If M is the middle, then AM has to be the same as MB because M is in the middle. A postulate. So a postulate is something that someone has proven for us that we can just accept as true. This is the segment addition postulate, and basically it says if I take AB and I add it to BC, it should be the same as AC. So if you take the two parts that are inside and add them together, it has to equal the whole. Just like if I said where, you know, I had $1 in my pocket and I pulled out 50 cents, I know that I had to have another 50 cents, and together they equal the $1. So the pieces equal the whole. All right, so we're going to practice with some justifications, and we're going to do a matching, basically. So if PQ equals PQ, then segment PQ is congruent to PQ. So that's that congruence. Remember, because we have the congruent symbol. If K is between JL, then JK plus KL equals JL. See how it says between, so kind of meaning like the middle? So that is going to be your segment addition postulate, all right? Because they're in the middle. You add the two pieces together, it equals the whole. 3, segment EF is congruent to EF. EF is congruent to EF, I guess. So basically when we get to proofs, we didn't cover this, but let's say we have two triangles that look like this. And let's say this is E, and this is F, and this is A, and this is B. Well, technically, EF is part of two triangles, right? This could be triangle AEF and triangle BEF. But when you think about it, since this line is being used twice, the EF here equals the EF there. So we can say that EF is congruent to EF. So it's exactly the same like that. We call that the reflexive property of congruence. So reflexive property. 4, if RS is equal to TU, then RS plus XY equals TU plus XY. All right, so when we go ahead and we look at that, that is going to be the addition property. Because we're saying that this plus this equals that plus that. And since these are the same, and that means RS has to equal TU. So you see the addition here, it's the addition property. If AB equals DE, then DE equals AB. This is one where you write the line down, you can put the line down the middle, and if it flips over the line, it's the same. So that's going to be the reflexive property, or symmetric property. All right, so on to number 6. You see that y, if y is the midpoint of xz, right? So that means that y has to be in the middle of xz. So then xy has to equal yz. So if you think about it, right, just draw it out. You have x, z, and y has to be in the middle. So that would mean that xy equals yz. So that is your definition of a midpoint. If segment FG is congruent to HI, and HI is congruent to JK, then FG has to be congruent to JK, right? That's where you just kind of cut the middle out. Remember that? It's like the syllogism, right? So we're just cutting these out, and what's left are those two. And that is called the transitive property. If AB plus CD equals EF plus CD, then AB equals EF, right? So what happened here? Well, see how they're both being added with CD, but if I take those away, by subtracting them, all that's left is AB equals EF. So subtraction is subtraction property. If PQ plus RS equals TV, and RS equals WX, then PQ plus WX equals TV. So notice that it says here that RS equals WX. So instead of RS, can I just put WX here? And it would be equal to the same number. So that is substitution. It's a substitution property. If LP equals PN, and L, P, and N are collinear on the same line, then P is the midpoint of Ln. So basically, it's saying that LP has to equal PN. So that means it has to be a line with an L and an N with P in the middle. That's the only way that would work. And if they're equal, that means P has to be the midpoint. So that is your definition of a midpoint. If segment UV is congruent to segment UV, then the length of UV equals the length of UV, right? And that is the congruence. Again, definition of congruence. If CD plus DE equals CE, then CD equals CE minus DE. All right, so let's think about this. If I take CD plus DE equals CE, if I minus DE from both sides, these cancel out. And what I'm left with is CD equals CE minus DE, which is right here. All I did was subtract. So it's just going to be subtraction property. All right, so we're going to use this segment proof guide. Basically, these should match up to what we're given, and we have to assign it, to different ones. So we're going to use the reasons below to complete proofs 1 to 6. Right, so here we have DE and F, segment DEF. E is the midpoint of DF. So if E is the midpoint, that means that this is equal to this, right? And it wants you to prove that 2 DEs equal DF. Well, think about it. If these are equal, and this is half of DF, wouldn't 2 of them just be the same as DF? So think about it. if this whole line was 4, and this is 2 and 2, if I doubled this, wouldn't that still equal 4? So that's kind of the thought behind it. So what is the reason for E as the midpoint of DF? Well, it's right here, right? It's that, it's the given. So that's your given. Right? None of these say given. So given is given. All right, DE equals EF. Why does DE equal EF? Well, isn't that because this is the midpoint? E is the midpoint, so it would just be the definition of a midpoint. So let's go back to our guide here. Oh, look, a definition of a midpoint. It could be this one here. DE plus DE equals DE plus DF. That is the addition property. Why? Well, when you think about it, DE plus DE is the same as DE plus DEF. Why is that? Well, because they're the same, right? Doesn't DE equal EF? Two DEs equals DE plus EF. Well, the only thing that happened here, notice it just combined the two DEs. It combined like terms or simplified. So let's go back and see what's going on here. Nope, there's our given. Let's find one that matches here. Given, that's multiple givens. Oh, here we go. Multiple givens, midpoint, given. Oh, here we go. Given, midpoint. Right, so, it's giving them to us, and we just have to put them in a proper order. That's what it is. Then DE plus EF equals DF. That's the segment addition postulate, right? The DE plus EF equals the whole line. And then finally, two DEs equal DF. And the reason is that right here, we saw that DE plus EF, which is right here, equals DF. So all we're going to do is take this right here and substitute it for that. And when we get that, that's our final statement. Right, and there's your transitive property. 2DE equals EF. To me, actually, I would be honest with you. I don't like that rule right there. This would actually, to me, be substitution. Okay? Because all we're doing here is we're taking this term that's right here and substituting that. All right? So that's going to be substitution. Both are correct. I think substitution is a little easier to see. Next, we have this figure right here, KLM and LN. It says that KL is congruent to LN. So what I do with these figures are I like to mark them. If KL is congruent to LN, they both get a mark. So they're both the same. Now, LM, which is this line here, this line here, is congruent to LN. So these are all the same, right? It says L is the midpoint of KM. Well, why would L be the midpoint of KM? Well, you see how L is between K and M, and KL is equal to LM? So that means L has to be the midpoint. Excuse me. All right, so first thing, where do we know this from? Right, wasn't that given to us? And KL equals LN and LM, so KL equals LM, and LM equals LN, right? Definition of congruence. If things are congruent, they're also equal. Now, KL is equal to LM. Well, why is that? Well, transitive property. So basically what it's saying is that if you think about it, KL is equal to LM, So these two cancel each other out, because this can be written as ln equals lm. And you see how they're in the middle next to each other, so they kind of cancel out, and all that leaves is this. That's your transitive property. And then finally, L is the midpoint of Km, because that's going to be the definition of a midpoint. Now, you're going to find that a lot of these proofs all follow the same patterns, and I know they can be difficult, but it's just something we're going to have to get used to, because you are going to see a lot of them. All right, so given, well, let's look at this diagram first. We see that we have two intersecting lines, PQS and TQU. It says PQ is congruent to TQ. So PQ is congruent to TQ. And UQ is congruent to QS. We have to prove that PS is the same length as TU. So we're trying to prove that this line here is congruent to this line here. So first thing we always have is what's called, right, our given. Now, notice that these are the same statements just written with congruence and not congruence. So that's just going to be the property of congruence. And this just says PQ plus QS equals PS. So let's look at that. PQ plus QS equals PS. And isn't that the segment addition postulate, like TQ plus QU equals TU? So it's a segment addition postulate. Next thing we have is TQ plus QS equals PS. So it's saying TQ here plus QS equals PS. So we look at in the diagram, it says that TQ plus QS equals PS. When we look at it, we're just substituting PQ for TQ. So let's look at it here. Here's PQ, here's TQ. And now it says that TQ plus QS equals TU. Once again, we are substituting. PS equals TU. Well, see see how they both equal that? So that is the transitive property. And then you have the definition of congruence. Not the easiest one, to be honest with you. And if I were to write this out, I'm following the note guide, I might do this a little differently. All right, number 4, Q is the midpoint of JL. So, K is the midpoint of JL. So if K is the midpoint of JL, that means that this and this are congruent. M is the midpoint of LN, so these two are congruent. And it says that JK, this part here, equals MN, which is right there. So technically they're all the same. And we have to prove that KL is equal to LM. And we just saw that we did that. So we have our given. And it says that JK is equal to KL and LM is equal to MN, because that was, well, so JK equals KL. Yep, because those are definitions of a midpoint, right? It says that JK equal to KL and LM is equal to MN. Then we have JK equals MN. Well, that's going to be a given, right? It's right there. Finally, well, not finally, MN equals KL and LM equals MN. That's just substituting stuff because we know they're all equal to each other because we proved it here. So we can just move them around. We know all of these can be the exact same, so they're interchangeable. Transitive property, right? All we did was take something and cancel it out. Right? We cancel out LM and, LM and MN. We got KL. Oops. Cancel out the two MNs. So we're left with this. Then we go ahead. We have the symmetric property, which just flips them around. And then finally, we have congruence, because all we're doing is changing the sign to congruent. If they're equal, they're congruent in this. Number 5, we have two segments here. It says that segment XY is congruent to segment UV. And it says that YZ is congruent to TU. So we always start with a given. Now it says that XY is congruent to UV. And YZ is congruent to TU. The reason, equal to, and the reason is all that's missing is the congruent sign. So that's going to be definition of congruence. Then it says that XY plus YZ is going to equal XZ. Well, let's look at it. XY plus YZ equals XZ. That's addition, right? The segment addition, same thing here. Then it says that UV plus YZ is going to equal XZ, right? Because this plus this is going to equal this line because UV and XY are the same, right? So all we're doing is substituting things. Then finally, XZ equals TV. So XZ, which is XZ equals TV. Why? Because it's transitive property. See how you have XY and TV, they're both equal to each other, and all of these just cancel each other out. Then finally, congruence. See how they're very similar in some ways? I know it's a lot to take in, and it's slightly overwhelming, but we'll get better and better at it as we do it. All right, we have two intersecting lines. It tells me that YW is equal to YZ, is congruent to YZ. And we have XY to VY. So that is our given, which is what we start off with. We have to prove that segment XZ is congruent to VW. All right, so WY equals WZ, right? All we're doing here at these statements are removing the congruent symbols. That's definition of congruence. Then we're saying that XY, which is right here, plus YZ equals XZ, right? That's the definition, segment addition postulate. We're adding these two together. Same thing, Then we have YV plus YW. So YV plus YW equals XZ. Oh, so we're just substituting because we know that they are equal from this step here. Then we have YV, VY, and YW equal VW. That's your midpoint again. Segment addition postulate because Y is the midpoint. And then you have XZ equals VW, right? What we're doing is the transitive property. Basically, we're taking these and we're eliminating this over here. And then finally, all we've done is change that symbol so it's congruence. All right, let's move on to number 7. Number 7, we have a triangle here, and it says that E is the midpoint of AC. So if E is the midpoint of AC, that means these two are equal, correct? And it says that DE equals EC. So DE equals EC. And that means that this is equal as well, correct? So we know that this is given. And then we have to fill in the rest. So that's all in a know. So let's go ahead with, how do we prove that DE is equal to AE? Well, we know that these two are equal, and we're trying to prove this this one right here. Well, we know that AE is equal to EC. How do we know that? Right? Isn't that the definition of a midpoint? Right? You're given this given, so you're just going to write that down. It's right here. The next one, you're given this reason. Why is AE equal to DE? Why is AE equal to DE? That's the question. Well, that is the transitive property, right? All we're doing, if we eliminate this, we're left with these two. Then we have the definition of a midpoint. Well, that would make AE equal to EC. AE equal to DE. Oh, definition of congruence. Excuse me. That is this statement right here. And then finally, you're given DE is congruent to AE, and that's just a symmetric property. All they've done is flipped it around to make it match what it's asking for. Right? These proofs can be somewhat clumsy sometimes. All right, so RS equals 1/2 of RT. So basically it's saying that RS is half of RT. So when you think about it, if this was 4, and this is 2, right? That's half. What does this have to be? 2. So what does that make S? It makes it the midpoint. So how do we know this first statement? Well, it is given to us. How do we know that 2RS equals RT? Well, think about it. If we multiply this by 2 and multiply this by 2, those cancel out and we're left with that. So all we did was multiply. RS plus RT plus ST equals RT. Well, that is your, right, segment addition postulate. Then you're given 2RS equals ST, RS plus ST. Right? That is your transitive property, because all we're doing is getting rid of something in the middle. I'm sorry, substitution. Ooh. Having a moment. Anyway, substitution, because what we're seeing here is that this right here equals this, correct? At the same time, we know that RT equals these two. So where RT is, you can put RS plus ST, and that's the substitution part. Next, RS equals ST. So here is your RS equals ST, because we're just subtraction property, right? All we're doing is we're taking this RS and minusing it, and when we minus 1 RS, we get, from 2 RS's, we get 1 RS. Right, and then you're given definition of a midpoint, so where that is what it's asking for, S is the midpoint of RT. All right, number 9, M is the midpoint of LN. So here is LN right here. So M is the midpoint, which is right there. N is the midpoint of MNO. So that means these are congruent as well. We have to prove that LM is congruent to NO. So when we look at this, M is the midpoint of LN. That is given. LM equals MN. Well, that's the definition of a midpoint, which is given to you. Right? Then you're given another given, and obviously the other given is what's written right here. You're given MN equals NO. Well, MN, which is right here, equals NO, because that's because N is the midpoint, so that's your definition of a midpoint. Then the transitive property of equality, well, what does that do for you? Well, that means we cancel out the two MNs. We're left with MN equals NO. And notice that all we're going to do is add a congruence sign in the symbols, which is congruence. All right, here is number 10. We are given nothing, right? So we have to do it all from scratch. So let's talk it out here. You could try 10, 11, and 12 and pause me if you want, and then come back and check it out. But y is the midpoint of xz. So if y is the midpoint, these two are congruent. And it wants you to prove that xy is equal to 1/2 of xz. Right? So first thing we're always going to do is write our given down. All right, so next thing we know is that xy is equal to yz. Why is that? Because that's the definition of a midpoint. And what will happen is that we know that 2xy's will equal xy plus yz. Why is that? Well, that's just the addition property. We know that this plus this will just equal 2 of these because 2 of those equals xz. All right, next thing we have is xy plus yz equals xz. That is your segment addition postulate, right? xy plus yz equals xz. Next, we know that 2xy's equal xz, right? That's just substituting, right? We saw right here that 2xy equals this plus this. So we can take these and substitute them out for this. Then you get xy equals 1/2 of xz. Well, that's just by dividing by 2, so that would be division. And then we are completed. Right? Because this statement matches this statement. All right, number 11. It says that AC, which is this whole thing, equals DF. Right? And it says that BC equals DE. So BC equals DE. We have to prove that AB equals EF. So first thing we're going to do is we are going to write down our given. All right. So next thing I would do without looking is I would get rid of these congruent symbols and say they're equal to each other. Oh, matched. And that's just congruence. Right. Then I would say that AB plus BC equals AC, right? Because that's that segment addition postulate. Same thing here, DE plus EF equals DF. Then you have AB plus DE equals DF. So AB plus DE equals DF. That is just literally substituting things, right? Because we know that DF, because AB, it says here, where's, we know that BC equals DE. That's what we're substituting. AB plus BE equals DE plus EF. Right now we're just doing the transitive property because we're getting rid of stuff. Right, when we look at this, you have your AB plus DE equals DF. And you have your DE plus EF. So see how we're getting rid of the two DFs and making them equal to each other? Then you have AB equals EF. because we're going to substitute, we're going to subtract. When you think about it, right, we are minusing, giving us that. Then finally we have AB equals EF because we just changed it to a congruent symbol. All right, finally number 12, the last one. But don't worry, we're going to have practice on this. Right, we're always starting with our given, and we are told that AB is equal to CD. So AB is congruent to CD. We have to prove that AC from here to here is congruent to BD, which is from here to here. So basically, we're just saying that when we add BC to both of these, they should be the same, which they are going to be. All right, so first thing we do is we're going to lose that congruent sign. Gives us definition of congruence. Next thing we're going to do is we're going to say that AB plus AC plus CD equals AD. Right? That's that. We're saying that all of this plus this equals the whole line. And then AB plus BD equals the whole line. So two ways of saying that when we add all these things together, they equal the whole line of AD, which is the segment addition postulate. All right, number 4, we have CD plus BD equals AD. That's going to be our substitution because we know that AB equals CD. AC plus CD equals CD plus BD. The reason is that is the transitive property. When we go search it out again, right, you have AC plus CD, which is right here. And then you have CD plus BD. And see what's missing? Number 6, AC equals BD, right? We're just subtracting CD away from both sides. Then finally, we're adding a congruent sign for definition of congruence. Now, you see how all of these are done very similarly? Now, when you go and you do your homework on this stuff, just keep all of this handy. You'll be able to piece it together. A lot of it is extremely similar. All right, so if you have any questions, we'll go over this some more. But let me know, and I will talk to you next time.